Okay, so lesson 6.2 talks about trig functions of angles. So let's go back and kind of review from geometry this whole SOHCAHTOA idea. I know you guys remember that. So sine, which is full on spelled out like that, but this is how we abbreviate it. Sine is opposite over hypotenuse. And then cosine is adjacent over hypotenuse. And then tangent, which is spelled out like that, is opposite over adjacent. Okay, so the three that you probably don't know as much about are cosecant and secant and cotangent. The good thing is they kind of match up with these three because they are reciprocals. So this one is the reciprocal, cosecant is the reciprocal of sine. So instead of being opposite over hypotenuse, it is hypotenuse over opposite. And then same thing with secant, that one is hypotenuse over adjacent. And then cotangent is adjacent over opposite, sorry. Okay, so there's those basic ones, right? So something else that they just want to point out and make sure you really know what they're talking about here is these reciprocal identities. So that's what I was mentioning here, that these are the reciprocals of one another. So sine is really the same thing as 1 over cosecant. And cosecant is the same thing as 1 over sine. And then cosine is the same thing as 1 over secant. And secant is the same thing as 1 over cosine. And then tangent is 1 over cotangent. And cotangent is 1 over tangent. So those are just my reciprocal identities. And in your book, they give you all of this information. It's just very spread out throughout this lesson. So I wanted to make sure I mentioned all of those things. And there will definitely be more in a minute and more identities to talk about. Okay, so this first example, they said if theta is an acute angle and cosine of theta is 3 over 4, find the values of the trig functions of theta. So the very first thing I would do in a problem like this, because they're giving me this information, I really want to see that in an actual triangle. So if I have a triangle over here, and I know that we're talking about theta, that angle. So here's my right angle. Sorry about my terrible triangle there. Okay. I know that if this is the angle that I'm talking about, this is the adjacent angle to that. This is the, side, the adjacent side to that. This is the opposite side to that, and this is the hypotenuse, right? So if they're telling me that I have the cosine of theta, cosine is the same thing as adjacent over hypotenuse. So adjacent over hypotenuse is what I have here. So I'm going to write it out, adjacent over hypotenuse. So that tells me that 3 is my adjacent side and 4 is my hypotenuse, right? So now the only one that I don't know is my opposite side. But if this is a right triangle, I can use Pythagorean theorem to find that. So I'm going to do that in a second. But they want me to find the values of the trig functions, meaning every trig function. So I'm going to have to find sine, cosine, tangent, cosecant, secant, cotangent. Okay? Once you know all three sides, that's very easy to do. So let me find my... use Pythagorean theorem to find my opposite side. So I'm going to do a squared plus b squared. I don't know what this one is, so I'm just going to call that x equals hypotenuse squared, right? So that would be 9. That would be 16. If I subtract 9, I get 7. So x is going to be plus or minus the square root of 7, but I'm only going to worry about the positive because we're talking about the length of a side of a triangle, right? So this opposite side is the square root of 7. So now that I have all three of those, I can write out my trig functions really, really easily. All right, so let's start with sine. Sine is opposite over hypotenuse. So my opposite was square root of 7 over my hypotenuse was 4. Cosine, they already told me what cosine of theta was. It was 3 over 4, so I don't really have to find that one. Tangent of theta is opposite over adjacent. So in this case, that's square root of 7 over 3, right? Now, the others, I'm not going to worry about looking back up here and saying, oh, it's hypotenuse over opposite or anything like that. I'm just going to use the reciprocal of these. So this one is my cosecant. It is going to be 4 over square root of 7. Now, I want you to be careful with this because a lot of times they want you to make this denominator not a square root, okay? If they do that, what they mean is they want you to multiply by the square root of 7 to get that out of there. And that's going to give me 4 square root of 7 over the square root of 7 times the square root of 7 is the square root of 7 squared, which is just 7, right? So this is typically how they want you to write it, okay? And you'll get used to that after a while. All right, secant of theta then is going to be 4 over 3. And then cotangent of theta is going to be 3 over the square root of 7, and then I'm going to do the same thing I did up here. If I multiply by the square root of 7, that gives me 3 square root of 7 over 7. Okay, so that's how you would do that problem. This right here would be your answer. All right, and then, so example 2, they're looking at these like specialty triangles, and I know you talked about these in geometry a little bit, so 45, 45, 90 triangles and then 30, 60, 90 triangles. So let's talk about the trig functions of those. So typically when they're talking about triangles, they're looking at like this idea that we have a triangle on a circle. So let's say I've got it like this, right? This is typically a radius, right? So the easier the values that we use here, the easier it is to define these trig functions. So let's say I call my side values on this one 1. That's because if I have a 45, 45, 90 triangle, that means these two sides have to be the same, right? So if I come up with those two values, then I can find this hypotenuse very easily by using Pythagorean theorem. So 1 squared plus 1 squared equals whatever my hypotenuse squared is, right? So that would be 1 plus 1, which is 2. So the square root of 2 is my hypotenuse. Again, I'm using only the positive value. So this is the square root of 2. And you've seen this type of triangle before, but that's how they came up with those values. All right, so then if I go back and look again, what is my sine of 45? Or if I'm looking at this angle right here, sine is going to be opposite over hypotenuse. So that's going to be 1 over the square root of 2. But again, I don't like the square root in the bottom, so I'm going to multiply by the square root of 2 on top and bottom. That gives me 1 square root of 2 on top, or just square root of 2, over 2 on bottom. Now my cosine of 45, because you end up with adjacent over hypotenuse on this one, it's the exact same answer. So this one again is going to end up 1 over the square root of 2, which simplifies to the square root of 2 over 2 again. The tangent of 45 is your TOA, right? So opposite over adjacent. That's 1 over 1 in this case, or just 1. So these are specialties, meaning you don't have to look these up if you just, well, okay, so let me go back for a second. You may have to look them up, but they're already solved for you. You don't necessarily have to do this every time you need that value. You can just go back in your book and look in the table, right? And after a while, this will just kind of become secondhand. So you'll just have it memorized, in other words, because we'll use it so much. The cosecant of 45, then again, I'm not going to do any work to find those. I'm just going to do the reciprocal. So I'm going to start back over here and say that's really the square root of 2 over 1, which is just the square root of 2. Same thing with this one. Square root of 2 over 1, which is just the square root of 2. And then this one, 1 over 1, which is 1. So there's those 3 values. All right, finding a 30, 60, 90 value. This one is a little bit weird. So how they came up with these values is they really thought of this as one larger equilateral triangle, because if this right here is also 30, then that's 60 degrees right here. This is 60, this is 60, meaning all of these sides are the same. So what they did is said, well, if I want just this value right here to be a 1, that means this is also a 1, which means all of these other sides are 2 altogether, right? I've got 2 there all the way across. So my hypotenuse is 2, this is 1, so this opposite side right here, my adjacent side is 1. I need to figure out what my opposite side is in this case. Or if I'm looking at 30, I'm looking at my adjacent side. Okay, so again, I'm going to use Pythagorean theorem to do that. So I've got a 1 squared plus, I don't know this one, I'm just going to call that x squared equals 2 squared. So 1 plus x squared equals 4. So x squared equals 3. So x is the square root of 3. So this right here, this value on this side is the square root of 3. Then I can go through and fill in all of my values again. So sine in this case would end up 1 over 2. My cosine would end up the square root of 3 over 2. And then my tangent would end up 1 over the square root of 3. So then let's see if I can simplify any of those. These two are fine. This one, I don't like the square root in the bottom, so that's really the same thing as saying I've got the square root of 3 over 3. If you don't understand how I'm getting from here to here, please let me know and I can talk you through that again. But I'm just multiplying by the square root of 3 on top and bottom. That's what I'm doing there. Again, my cosecant, secant, and cotangent, I'm just going to flip. So this would be 2 over 1 or just 2. This one would be 2 over the square root of 3, or let's simplify that. That's 2 square root of 3 over 3. And then this one would be square root of 3 over 1, which is the square root of 3. All right, now that was me looking at 30, right? So I didn't really point that out very well. I should have pointed that out. I was looking at angle 30 right here. This side down here is me looking at angle 60, that angle, right? So this one was probably the more like obvious one because it's how we've done all of the other ones. This one was a little off. So again, when up here, when I said the sine of 30 was 1/2, that's because that was opposite over hypotenuse, right? In this one, opposite over hypotenuse is going to be the square root of 3 over 2. I didn't make that very clear at all, so hopefully that cleared that up. And then this one, my cosine of this would be my adjacent over hypotenuse, which is 1 over 2. My tangent would be the square root of 3 over 1, which is just the square root of 3. The other two don't really need simplified. And then I'm going to reciprocal those, so 2 over the square root of 3, which is the same thing as 2 square root of 3 over 3. This one, the reciprocal is 2 over 1, or just 2. This one would be 1 over the square root of 3, which is just the square root of 3 over 3 when I multiply that out. Okay, so again, your book gives these values, but I wanted to kind of let you know where those came from. It's just your basic SOHCAHTOA, finding those values. Sometimes you have to find an extra side using the Pythagorean theorem, but that's pretty much it. So what they're giving you also in your book, this right here is really important. This is typically in the front cover of books once you learn it. So the definition of trig functions of any angle at all. So this is us looking at, I've got this point right here, and that point is x comma y, right? That means that this value is going to be whatever that x value is, right? And I went up that y value amount. So let's say I'm at the point 2 comma 5, then x is 2, y is 5, right? And then r is that radius, or in our case, the hypotenuse. Right? Radius meaning if I had a circle drawn here, that would be the radius of that circle, if this is the center. Okay, so my sine value is always, if you're looking at theta, it's opposite over hypotenuse, which in this case is going to be y over r. So your y value is always your sine value. Cosine is your x value, so x over r. Tangent is always sine over cosine, so that would be y over x. Now, one little piece of information here, x cannot be 0 because then my denominator would be 0, right? So that's not okay. All right, cosecant, again, let's just use the reciprocal. So r over y, this one would be r over x, this one would be x over y, but you have to kind of give that little disclaimer that y can't be 0 in that case, x can't be 0 in that case, and y can't be 0 in that case. So just keep those in mind. Okay, so let's do this example here. So example 3 says a surveyor observes that at a point A, which is located on level ground at distance 25 feet from the base of a flagpole. Okay, so I've got this flagpole over here, right? And at the base of that flagpole, which they call B, on level ground away from that is this point A, and it is 25 feet away. Okay. All right, then they said the angle between the ground and the top of the pole is 30 degrees. So from the ground to the top of the pole, it would help if I had pencil, here we go. To the top of that flagpole right there is 30 degrees. So this right here is 30. And they want me to approximate the height of the pole to the nearest tenth of a foot. So the height of that pole right there. Okay, so let's talk about how we can do that. First of all, I know angle 30, so that's the one that I'm going off of. And the only two values that I really have here are that I need to find h, and I know this 25. So what values am I thinking about here? I know that I have my opposite, and I know that I have my adjacent, right? So which trig function deals with opposite and adjacent? That would be tangent, right? So my tangent of 30, and I'm talking degrees here, so please make sure you're paying attention to whether you're talking about degrees or radians. They gave me 30 degrees. That equals opposite over adjacent. So in this case, that is h over 25, right? So now if I'm solving for h, I can multiply by 25. And that's going to give me h. So on my calculator, I'm going to do two things. First, I'm going to make sure that I have it in the correct mode. So if you don't know how to check the mode on your calculator, I want you to please get used to doing that now. And in the very top in mine, I'm not sure where it will show up in yours, so maybe check this on yours. I have degrees, radians, or gradians. I am only going to have to worry about degrees and radians right now. So degrees are first. Radians are second. Mine is in degree already, so I'm good to go. Please make sure you have it in degrees. Okay, then I'm going to calculate that. So I'm going to take the tangent of 30 degrees, so tangent of 30, and then I'm going to multiply that by 25. You could also just type in 25 tangent 30 like that and get the same answer. Some calculators are a little more finicky than others, so I just caution you on that. So I ended up with about 14.43. They said to round to the nearest tenth though, so I'm just going to go 14.4. So 14.4 is about h, and I'm leaving a space here for my units. I need to go back and think about that, and it was in feet. So about 14.4 feet. Okay, so before I end this first video, I want to talk about two more little things real quick. We already talked about degree versus radian mode on a calculator, but I want you to pay attention to things like, does it say the tangent of 30 degrees, or does it just say the tangent of 30? Those are two different things. So if I did the tangent of 30 degrees, you saw that earlier, so tangent of 30 degrees is this. Well, what if I had it in the wrong mode? So let's go to radians for a second. Then I do tangent of 30. That's going to give me a totally different answer. So this is really important to make sure you have it in the right mode. So I'm going to put it back in degrees, and then that should put me back into that over there. The other thing I wanted to mention is, how do I find things like cosecant and secant and cotangent? Well, I want you to remember that reciprocal. identities, right? So if I'm finding cosecant of, let's say, 30 degrees, okay, so I'm going back to my 30 degrees again. This is the same thing as saying 1 over sine of 30. So if I had to calculate this, I would probably just say, well, what is the sine of 30? So sine of 30 degrees. And then I would do 1 divided by that answer. And that would give me 2 in this case. Another way that you could do it, though, you could say, give me the sine of 30, which is that reciprocal value, right? Give me that answer. And then hit this x to the -1. That will also give you the correct answer. So that just takes it to the -1 power, which is 1 over that, right? So that's another way to do it. So when you get stuck on cosecant, secant, and cotangent, that's how you can calculate those on your calculator. Okay, we'll do the rest in the next video.